Solving example 2, the solution. As you may recall, we are looking for values of x for which the f prime of x is less than 0. Then the f prime of x is given to be 24 minus 6x minus 3x squared being less than 0. And recall, from solving quadratics, inequalities, and the factorization video, which I encourage you to check out because they have a lot of insight. Now, continuing. Dividing throughout by 3, we are going to get 8 minus 2x minus x squared less than 0. And of course, we can actually multiply throughout by a negative so that the sign changes from less than to greater than. So in that case, we're going to have x squared plus 2x minus 8 is greater than 0. This implies that the f prime of x is equal to x plus 4 times x minus 2 is greater than 0. Therefore, for us to find the critical values, we are going to equate each and every term to 0 so that we have x plus 4 is equal to 0 or x minus 2 is equal to 0. And solving for x, we get x is equal to minus 4 or x is equal to positive 2. F prime of x is a parabola with a minimum point. I'm sure we know how. Check out our quadratics list in order to get more info on how to find such. Welcome to Numbers Simplified. In this channel, we seek to simplify and solve numerical problems. Today, we'll be looking at differentiation, especially increasing and decreasing functions. Take note, this is part 6. Subscribe so that you don't miss out on any of our future uploads. We have covered many playlists, so make sure you check them out and subscribe. Leave your comments, questions, and answers. We'll be glad to assist. Now continuing, a function f of x is said to be increasing if that f of x is increasing as the x values increase, or f of a is less than f of b, where a is less than b. These are the x values. Then, according to the graph, we can see here the f of a is lower than the f of b, whereas on the x-axis, a is less than b. That is what we implied. Therefore, f prime of x is greater than 0 for the x values that are greater than a, since the gradient of an increasing function is positive. Let's check out the other part. A function f of x is said to be decreasing if f of x decreases as x values increase, or mathematically, f of a is greater than f of b, where a value is less than the b value. Then, according to the graph, we can see that a is smaller than b, but the f of a is actually greater than the f of b. And as we see, the graph is decreasing as we are moving towards the further x values in the positive. Therefore, f prime of x is less than 0 for x is greater than a. Then the gradient of a decreasing function is always negative. With that information, let's check out our first example for the day. Example 1. Find the set of values for x for which the function is increasing. F of x is equal to x squared minus 8x plus 2. The solution. So we are going to look at two methods on how to answer the question. Method 1, using the differentiation approach. Recall, we are looking for values of x for which the f prime of x is greater than 0. So we know what our f of x is. Now if we differentiate the f of x, we are going to get f prime of x of 2x minus 8 is greater than 0. From there, we move on to solve for x, implying that we are going to have 2x is greater than 8. And solving for x, we have x being greater than 4. Therefore, for all values of x that are greater than 4, the function f of x is increasing. Let's take a look at method 2. Using the completing the squares method. And I encourage you to check out the quadratics list once again, specifically the completing the squares method when dealing with quadratic equations. That could be helpful. Now, from our f of x, we can actually find the equivalence of this quadratic in terms of completing the squares method, so that we get x minus 4 squared minus 4 squared plus 4. Now with that, simplifying further, we are going to get f of x being x minus 4 squared minus 14. And take note, f of x is a parabola with a minimum point 4 and minus 14. And I encourage you to check out the quadratics list. We cover this in great detail. Now, if we are going to plot or sketch the graph, we are going to have something of this particular manner with the minimum point 4 and minus 14. With that, it is evident that the f of x increases for all x values that are greater than 4, because from the point 4 on x, moving further to the right, the graph increases. And that's the alternative method of solving this particular question. Let's take a look at example 2. Find the set of values for x for which the function is decreasing. The f of x is equal to 11 plus 24x minus 3x squared minus x cubed. The solution. As you may know and recall, we are looking for values of x for which the f prime of x is less than 0. Then it means that we are going to find the first derivative of f, that is f prime of x is equal to 24 minus 6x minus 3x squared is less than 0. And recalling from the solving quadratics inequalities and the factorization method videos, I encourage you to check these videos. They carry a lot of insight. We know that the f prime of x is less than 0, and of course we can divide throughout by a negative 3, or let me start with a positive 3 so that we get 8 minus 2x minus x squared is less than 0, and multiplying by a negative so that the less than sign changes to greater than sign. Therefore, we have x squared plus 2x minus 8 is greater than 0. Implying that the f prime of x, when factorized, is going to give us x plus 4 times x minus 2 is greater than 0. This is from the factorization method of quadratics that we covered on Numbers Simplified. Therefore, the critical values are obtained by setting the x plus 4 is equal to 0 or the x minus 2 is equal to 0, so that we get x values of minus 4 and 2. F prime of x is a parabola with a minimum point. These are concepts that we covered on sketching quadratic graphs, so check the videos out so that you get more details. Now, sketching this particular f prime of x, we are going to get a parabola that has got a minimum point that passes through or intersects the x-axis at minus 4 and positive 2. Therefore, f prime of x is less than 0 is satisfied on x is less than minus 4 or x is greater than 2. This will be our answer. Let's dive into example 3. A function f of x is equal to 5 over x plus 2 squared minus 2 over x plus 2 for x values greater or equal to 0. Find an expression for f prime of x and determine whether f of x is increasing, decreasing, or neither. So the solution. We know the f of x can actually be expressed as 5 times x plus 2 to the power minus 2 minus 2 times x plus 2 to the power minus 1. This comes from the laws of indices. And I encourage you to check the indices video out. And also, make sure to check out our differentiation by substitution and chain rule part 3, because that is what we are going to apply in differentiating f of x. Now we let u, which is the inner function, that is x plus 2. In order for us to find the du dx, we are going to differentiate that so that we get a du dx of 1. And also, we know that f of u now, instead of having x terms, we are now substituting that with the u terms. F of u becomes 5 times u to the power minus 2 times u to the power minus 1. Then we get the df du being minus 10 u to the power minus 3 plus 2 times u to the power minus 2. Therefore, the f prime of x becomes df du times du dx from the chain rule, and we substitute for the df du and the du dx. Afterwards, we substitute for u that we had actually assigned, so that we have the f prime of x becoming minus 10 times x plus 2 raised to the power minus 3 plus 2 times x plus 2 to the power minus 2. Subscribe so that you don't miss out on any of our future uploads that contain other differentiation approaches which might be beneficial in differentiating. Now, moving on, the f prime of x becomes minus 10 over x plus 2 to the power 3 plus 2 divided by x plus 2 squared. Now, we can actually combine the two fractions to one fraction so that we have the numerator is minus 10 plus 2 times x plus 2 all over x plus 2 cubed. Now, simplifying further, our f prime of x becomes minus 6 plus 2x in the numerator, and the denominator remains the same. Great then. If we have our f prime of x, what we move on to do is we consider the numerator, because whatever happens here, we can always get certain values. And considering the numerator first, of course, we can consider the denominator as well, but considering just the numerator, we have a minus 6 plus 2x for x is greater or equal to 0. That would imply that the f prime of x can either be decreasing, that is from the range of x starting from 0 to less than 3. If we substitute the values that are between 0 and 3, we see that we are going to get the f prime of x, which is negative, implying that the graph is decreasing in that particular domain, that is for the x values. And also, we see that if we substitute for values that are greater than 3, we are going to have an increasing function. So with that, we cannot conclude whether this is an increasing or decreasing function, so the best answer here would be neither. And that's how we would solve this particular question. Let's take a look at the final example. Example 4. A manufacturing company produces X articles per day. The profit function P of X can be modeled by the function P of X is equals to 2x cubed minus 81x squared plus 840x. Find the range of values of x for which the profit is decreasing. The solution. So we know that p of x is equals to 2x cubed minus 81x squared plus 840x, implying that p prime of x, which is the derivative of p of x, becomes 6x squared minus 162x plus 840, which is less than 0. And take note, the profit is decreasing. That's why we are setting it to less than 0. Now, dividing throughout by a positive 6, we are going to get x squared minus 27x plus 140 being less than 0. And using the quadratic formula in order for us to find the critical values, I encourage you once again to check out our quadratic formula video from the quadratics list. We covered this in great detail. Now, this is our quadratic formula. We substitute for the values and we get that. So implying that x is equals to 27 plus or minus 13 over 2. And separating the positive from the negative, we are going to get the x of 20 or x being equal to positive 7. Now with that, these are the critical values. Therefore, the function x squared minus 27x plus 140 has a minimum point. You would know from the sketching quadratics graph video how we determine this. If we sketch the graph, we are going to have a graph of this particular nature where the p prime of x is negative when we have x values that are between 7 and 20. So this is how we would solve this particular question. And make sure you check out our quadratics list because there is a lot that we covered and that might be beneficial to you as well. With that, I'll leave you with the following task. A curve has equation y of x is equals to x cubed minus 6x squared minus 15x minus 7. Find the range of values of x for which y of x is increasing and decreasing. Thank you so much for watching Numbers Simplified. Remember to post your answers to this particular question and even post your very own questions. And we will do our very best to assist you in each and every question that you will post. And I'll do so for the first 5 people to post their questions. And remember once again, God loves you.